going to talk about, well, we talked about probability and random variables and all that stuff before. But now we're going to talk about how to calculate like the mean and the standard deviation of these random variables. Okay, so we've done a lot of stuff with mean and standard deviation before, but we haven't done anything with probabilities yet. So whenever we're talking about the mean and standard deviation of a probability of things, this is kind of the process that we are going to go through. Okay, so before we get into the notes, I want to do 2 review questions, okay? We're going to talk about the population. I actually don't think we talked about the sample mean. So when we have a population of things and we're talking about the mean, do you remember what the symbol of the mean is? The U. Yeah, the U with like the long like tail to it, right? This is the symbol that we used, right? Okay. What about variance? Anyone remember variance? Oh, the slash? Yeah, it's actually the Greek letter for sigma, but it's lowercase. The one on top is mu, okay? But it's not just this, it has a little square on top. Okay, so it's sigma squared. And then standard deviation is the sigma without the square, right? And remember, you take the square root of the variance to find the square root. So we're kind of back in these mindset using these symbols, okay? Okay, so I'm going to tell you how to find the mean and the standard deviation of a probability distribution, okay? And we're going to call this probability distribution a discrete random variable because we can put stuff into a chart and find the probability. So what we're going to do here is, I don't mean to scare you when I write these formulas down, okay? Just bear with me while I write them down, okay? So when we're trying to find the mean of a random variable or discrete random variable or something like that, we're going to use the symbol mu, okay? But to say that I'm talking about probabilities and the random variable x, I'm going to put a little x at the very bottom. Okay, so it's the same symbol, except I just put a little x at the bottom, okay? And here is the formula. Don't be scared, okay? It's uppercase sigma, bracket, x times p of x, close the bracket. This is the symbol or the formula for the mean of a random variable. Okay. Now, before we get scared by the formula, let's try to break down this formula and try to see what it actually means, okay? So looking at the formula, there's this weird squiggly symbol up here. It kind of looks like a backwards E. Does anyone know what that means?
Sum of.
Yeah. Let me write that down. I'm actually going to write exactly what you said. The sum of. Okay, so whenever you see that squiggly backwards looking E thing, that means take the sum of whatever comes after. Okay, so then we have these brackets, which basically contain what we want to take the sum of. So it's basically saying take the sum of x times p of x. Okay. And this is for every single x and its probability. If that doesn't make sense, I think the example will show a little bit better, okay? If you don't want to think of this in the formula sense, you can also think of finding the mean as first multiplying each x value and the probabilities together, the inside of the bracket. Step 2, just add up all the numbers that result, okay? So one thing about this formula, you don't need to memorize it. I'll always give it to you, okay? So don't need to memorize. But you should be able to read the formula and remember the steps based on what the formula says. Okay. Another thing about the mean of a random variable, so the mean of probabilities, stuff like that, we can also call this the expected value. Okay, I don't really use that word a lot, but if you ever hear the term expected value, we're talking about the mean of a probability distribution. Okay, let's do an example here. Okay, so example 1, we have a computer monitor and it's composed of a bunch of these things called pixels, right? They kind of create all the lights and the colors on the screen. And some of them can be defective. A lot of the times you can't even tell if a pixel is defective as long as not too many of them are, okay? So we're gonna let X represent the number of defective pixels on any line, okay? We made a probability distribution that there are no defective pixels, 1, 2, 3 defective pixels, oh my gosh. And we wanna find the mean number of these defective pixels, or X, right? Okay, either using the formula or the steps, what should I do first? TJ?
I would just write the equation.
Oh, yeah, that's a good idea. Let's write down the equation. So mu x equals the sum of x times p of x. That's always a good step. Okay. Once I've written it down, what should I do?
On X by probability.
Good, good. So you can do this in two ways. TJ, since you wrote down the formula, you might want to write it like underneath the formula. What I like to do is just multiply across each of the columns, right? That makes it pretty easy. X is 0, the p of x is 0.2, so I could just multiply these two to get 0, right? I can multiply 1 by 0.5 to get 0.5. I can multiply 2 by 0.2 to get 0.4. And I can multiply 3 by 0.1 to get 0.3. Okay, so I kind of like doing it this way because it's like very organized and I can keep everything in a straight line, right? Okay, what's my last step here?
Just add all this.
Yeah, just add them up, right? So my second step would be to take these numbers and put plus signs in between them. Okay, so when I add them all up, you should get 1.2. Okay. So we got this number and it's the mean of something. Is this the mean of the probabilities or is it the mean X value? This is kind of a tricky question. It's actually the mean of the X values, okay? When we do the mean, we're interested in what we're trying to find the probability of. We're not finding the mean probability. So here we're kind of taking into account the probability of each of the X values. And what results is actually the mean number of pixels that are defective. Any questions on example 1? Okay, so let's go to the next page. Example 2 talks about a mineral economist. And before I let you take a crack at this, I kind of want to explain what this chart is even saying here. Okay, so this mineral economist went on this venture and finds probabilities of like $1 million losses. So $30 million losses, 20 million profit, 40 million profit, and etc. Right? So here we have a chart. On top, we have like the X values that represent either the loss or the profit. Okay, the negative 30 here means a $30 million loss, okay? And we didn't even put million there because in our heads, we can just kind of keep tabs and think of negative 30 as negative 30 million, 20 as 20 million, and so on, okay? So what I want you to do, use your notes from last time or from the last problem. Try this example. I'll be around to look at your answers. So I think I saw everyone answer, but Shalay, do you kind of want to do this example?
Those three numbers and then
Mhm. Awesome, right? So finding the mean isn't too bad. You just multiply the numbers and you add them all up. All right. Nice job on that one. Any questions on finding the mean? All right. Let's go to something a little bit harder, but it's kind of the same sort of process, just with different more steps, I guess. Okay, so now we're going to talk about the variance of a random variable, okay? So remember, the variance of any variable is sigma squared, right? So when we want to find the variance of a random variable, it's sigma squared with an x on the bottom, okay? Just like the mean. You just stick an X on the bottom of the sigma. Okay. All right, here's the formula for the variance. Don't be scared by it. I swear it's not as bad as it seems, okay? So first, sigma, okay? We have our brackets again, the x squared times p of x in the middle. The bracket closes and then we subtract off mu x squared. this is another formula that you don't have to memorize, okay? Don't memorize. I will give you the formula, but you should be able to read the formula and kind of see what sort of steps you have to take, okay? So let's kind of pick this one apart here. So I guess that squiggly symbol still means the sum of, right? Okay, so you're going to take the sum of x squared times p of x for every single of the x values, right? So everything inside the bracket is what you're taking the sum of, okay? So basically, this sum sign covers just right here, right? That's kind of where the sum stops, okay? So once you finish taking the sum, then you're going to go in and you're going to subtract mu x squared. Wait, mu x is the mean, right? So we're going to subtract the mean squared. Okay. So you can think of it using the formula. I also have a bunch of steps in a table that can help you organize each of your steps here. Okay. The first step, of course, find the mean. Okay. We know every single thing in this formula except the mean. So that's what you're going to have to find first. Okay. Step 2, you're going to square each x value. That puts us at the x squared, right? Once you're done squaring, multiply these square values by p of x, okay? Once you've done that to every single x value, you're going to take the sum. Once you got that one number, that's the sum, you're going to subtract off the mean squared. Okay. Now, before we get into example, we also have the standard deviation, right? So standard deviation has the same symbol as the variance, but we take off the squared. And how do we find standard deviation again?
Yeah, just take the square root of the variance.
Yes, the square root of the variance. So I just stuck the variance symbol inside a square root. Okay, you will have to memorize this. Maybe not all the symbols, but you should know that you have to take the square root of the variance. Okay. So let's try to apply this. I know there's a lot of steps here, but I think having a chart that organizes our information really clearly is going to help a lot with this calculation here. So example 3, we have the mean and standard deviation of this probability distribution. You want to find that. Okay, we've got x values up top, the probability at the bottom. Okay, first step is to find the mean. Okay, how about this? I'll find it over here. You can try to find it and try to get ahead of me here. But all you have to do is multiply across the columns and add them up, right? So I'm going to do it on my end. We'll see if we match. Does everyone agree that it's 1.2? Nice. Sometimes I mess up in my office, so I kind of get scared. Okay, so step 1 is done. We found the mean. Okay, that's one of the things that we need to know in our formula. Okay. Steps 2, 3, and 4, I'm going to combine in this chart here. Okay, so step 2 told us to take all the x values and square them. So we're going to do the same thing here. Okay, so under the x squared column, I'm going to take my x values and square them. So 0 squared is 0. I've got 1 squared is 1, right? 2 squared is 4. 3 squared is 9. All I did is square the x. Now the third column gets a little bit trickier because you're going to have to look away from this chart, okay? So this one tells us to take x squared, which was our last column in the chart, and multiply them by p of x. A little tricky. Okay. Let's try the first row here. We're going to take x squared, which is the last column. What number am I going to multiply by 0? And how do you find that?
Because that's what the that x value of 0 corresponds with that 0.
Yeah, so what you did here is you saw x as 0 on this row. So you looked over here and found that the probability of 0 is 0.2, right? So what goes here? 0.2. Okay. So we're multiplying 0 times 0.2 to get 0. Okay. Same thing goes for the second row. I'm going to take my last column, 1, and I'm going to multiply it by whatever I find the probability of x equals 1 to be. So since the probability of x equals 1 is 0.5, I'm going to multiply 1 by 0.5. Okay, that ends up being 0.5. Same thing for 2. I'm going to take 4 and multiply it by, I'll choose a different color, whatever the probability of 2 is, which ends up being 0.2. And that ends up being 0.8, right? Then I find the probability of 3 and multiply it by 9. So 9 times 0.1 is 0.9. Any questions on this step here? Okay, so once I've found all these values in this chart, all I have to do is add them all up. That's what step 3 tells me to do. So I'm going to do 0 plus 0.5 plus 0.8 plus 0.9, and that gives me a sum of 2.2. Any questions so far? Good. Okay, here's where things get a little crazy. Okay, I know that when we found variance and standard deviation before, we took the sum and divided by how many numbers there are. Okay, that's not the case here. We have a different formula since we're dealing with a probability distribution. So we're not dividing by anything. We're actually going to subtract this number by something else. Can anyone tell me what that number is? 1.2, good, but we have to do something to it. Square it, right? So this is a different process than finding the variance of like 4 or 5 numbers, okay? We're subtracting off the mean squared. Yeah.
Why 1.2?
Yeah, so, okay, let's take a look at our formula here. I think step 5, let me point to it here. It says subtract the sum minus the mean squared, right? So what I did is I was like, okay, the mean's in here. I need to find the mean. But we found that in step 1, right? Yeah, so let me make a little pointer to it. This is the mean from step 1. Okay. Now, one thing about finding the variance is a lot of people forget to square the mean. Okay, I feel like this is the biggest mistake people make. So make sure you square this mean. Okay, make sure you square it. So this becomes 2.2 minus, I think, 1.44. And I think that ends up being 0.76. So we found the variance. Then to find the standard deviation, you take the square root, right? So square root of 0.76 ends up being 0.872. All right, any questions on this example? All right. So if you flip the page over to the next one, you can try example 4. Okay, I want to do this as a class. And if you're done early, you can flip over to the optional example on the back. I have the answers there too, so you can check your answers. It looks like we're about done with example 4. All right, Emma, do you want to take the liberty in explaining all of example 4?
Sure. So I just multiplied each x variable by its probability, and then I added these all up to get 0.7. And then down the chart, I multiplied or squared each x variable. So I got 1, 0, 1, 4, and then I multiplied the x squared by its corresponding probability up the chart above. So that's how I got the first column. And then I added all those together to get 2.3. Then I plugged it into the variance equation, so it's 2.3 minus the mean from above squared, get 1.81, and then I just squared that.
That's great. Awesome. Awesome. Now, any questions on this example here? Yay. Okay. So I have an optional example on the next page. The answer is at the bottom. So if you want to, I'm not going to hold you here, but if you want to work on it now, totally good. I can look at your steps. But if you're done and you got the right answer, you are free to go.